Welcome to another episode. Today we will discuss about literals in Java. Let's start with a main.java file. Let us start with the typical Java boiler code. That is public class main, public static void main, let's start with a very simple integer. Let's name it index. And to print this value in the console, we can write system.out.print. As you all know what this statement does, it will just display the value of x in the console. Let's compile it and run. So it is printing 5. See this 5 here, we have just initialized into the variable x. This value is called a literal in Java. In Java, a literal is just a constant value that we can use to store in a variable or display here. For example, this printing here, this is actually a string literal. And this 5 here is an integral literal. Even integral literals can be classified into many. This 5, for example, is a base 10 literal. Base 10 literals are like normal numbers which use digits 0 to 9. For example, 10, 99, 55, 68, etc. But we can also use binary, octal or hexadecimal literals. I will show you how to declare a variable and initialize an octal literal to it. Octal literals use digits of base 8. That means its digits can range from 0 to 7. For example, 1247. This is a valid octal number. Even though it looks like 1247, the actual value in decimal is not 1247. But Java will still things like that. So how to inform Java that this is actually an octal literal? We will just put a 0 before the literal. Like this. Now Java will understand that this is an octal literal. Let's print x2 now. 679 is the correct decimal value of this octal number, that is 1247. Now what about hexadecimal values? Let's declare another variable. Hexadecimal values have 16 digits. They start from 0 and ends in E. For example, this is a hexadecimal value. To inform Java that this is a hexadecimal value, we can put a 0x before it. Like this. Now let us print x3. Therefore, 30892 is the decimal equivalent of the hexadecimal value 78AC. There is also binary literal. For example, let's declare another variable x4. And let's put a binary number 101. What does 101 translate to decimal value? It will be 1 plus 0 into 2 plus 1 into 4. That will be 5, right? If we just print x4, it will print what exactly we have written, that is 101, because Java doesn't know it is a binary number. So it is printing 101. For it to print 5, we have to specify it is a binary, like we did here. For binary literals, the leading code is 0b. Do note that you can use capital X or capital B as well. I'm just using small b for reference. Now if we print x4, it will print 5. So it is printing the decimal value, that is 5. In the last episode, we have studied about Boolean data types. Boolean data types can be used to store true or false literals into variables. For example, it is printing the value of x5 and x6, which are true and false respectively. In this case, true and false are the literals we assign to the variables x5 and xs. There is capital literals. They are used to store char values into a variable. For example, let's write char a. Maybe s. Now if we print a, it is printing s. But we can also store integers into a char. For example, if you write 65, it should probably print a. So it is printing capital A, because capital A is the Unicode equivalent for 65 number. So what will be the value of 66? You guessed it right, it's capital B. Other type of literals are floating point literals. As I have said in the previous episode, we have to put an f so that our compiler know that this f1 is actually a floating point variable. Let's print f1. So it is printing the value of f1. There is also double. For double, we don't need to specify a trailing d. You can do that, but it is not compulsory. For example, 3.14. It is printing 3.14 fine. You can specify a trailing d, but that is unnecessary. But for float literals, you must specify a trailing f. If you do not specify, it will give some error. Incompatible types. So these are some important literals in Java. We have 4 integral literals. One is decimal, another one is octal, then hexadecimal, then binary. Boolean literals are very unique. It's only true or false. Then there's scatter literal, string literal, and finally there are float and double literals. So this value highlighted is the literal, and the one I highlight here is the variable, and before that it's the data type. So data type, variable, and literal. It's very easy to remember. I'm giving you a small assignment for today. You just have to print value of pi is 3.14 in console. But make sure that instead of directly writing 3.14, you use a reference to a floating point literal. Thanks for watching.